So now let's get the name and let's go to the formula. And so the name to the formula is the exact same rules we've done every single time. So remember, the first one was to write the symbol and the charge for my cation. And remember, the first thing written is the cation, the second is the anion. So the first thing written was iron 3. So I have to know what's the symbol for iron. So the symbol for iron is Fe, and since it's variant, it tells me what the charge is. +3, and I know it's a plus because it's a metal. All metals are cations. Step 2 is the symbol and charge for the anion. Okay? So this says phosphate. It ends in ATE. So this is where we have to really pay attention. This is how I know that this isn't just P, phosphorus. Because remember, if it were just the nonmetal phosphorus, then this guy, his anion name would be phosphide, IDE. But if it ends in ate or ite, that's how I know it's a polyatomic. Okay? So refresh. If it is ate or ite, that's how I know it's a polyatomic ion. If it's IDE, then I know it's just a non-metal element, just the non-metal by itself. So it ends in 8. So if it ends in 8, it's a polyatomic. So I have to go to my chart and find phosphate. Okay? So I go to my chart, I look it up, and I find phosphate. And phosphate is PO4 3-. So that's what it is on my chart. So now I have both of the cations and anions. Step 3 was my cross down method. So Fe +3, PO4, and you can put it in parentheses, that helps sometimes. Cross down. You get Fe3, PO4, 3. Step 4 is to reduce. So they're both got 3's, so I can reduce by 3, and I can get FePO4. Now, a lot of times when it's just 1's, you'll see it as just FePO4. They don't necessarily leave the PO4 in parentheses if it's just one of them. You can write it either way, but this is the more technical way of writing it. All right, last way is to do our check. So I have one Fe at a +3, one PO4 at a -3, so it cancels out and it's neutral. So FePO4 is how you would write that from the name to the formula. All right, let's do another one. Like I said, best way to do this is practice. All right, so this one says an aluminum ion with a sulfate ion. So it doesn't give me the name, it just tells me the ion. All right, so I know this is the cation, this is the anion, because that's how it's written. So aluminum ion, I gotta know what is the symbol. So the symbol for aluminum is Al. Then I need to know the charge. So I go here and I find aluminum, go up, and he's a +3, okay? So he's a +3 charge. All right, sulfate, he ends in an 8. So since he ends in an 8, that tells me he's a polyatomic ion instead of being a element. So he's not sulfur, because if it's sulfur, it would end in IDE. So he's a polyatomic ion. So go to my chart, I'm not gonna flip there. So go to your chart and you'll find him, and he's SO4 2-. Okay, so SO4 2-. So now I have both of the ions. So now I can do the cross down. Al +3, SO4 -2, cross down. Al2, SO4 3. Sometimes people accidentally put the 3 here. Remember, this 4 stays with the O because it's how many oxygens are there. So don't mess up the 4 here, multiply it, or get rid of it, or whatever. So if you need to put this in parentheses so that you do it correctly, that's fine. All right, can I reduce that? It's a 2 and a 3, so that's a no. And then I do my check. So I've got 2 Als at a +3 gives me a +6. I've got 3 SO4s. Each of those are at a -2 gives me a -6. +6, -6, neutral. And in this case, because I have a subscript, I'm going to leave the SO4 in the parentheses because I have 3 of them. So Al2, and then in parentheses SO4, and then my subscript 3. All right, let's do the next one. Chromium 2 with hydrogen carbonate. All right, so I need to know what is the symbol for chromium. So that's Cr. And then I don't have to go to the periodic table because it told me right here what the charge is. And since it's the metal, it's a cation. And remember, cations are written first. So Cr +2. Then this is hydrogen carbonate. 2 things should help me know that this isn't just an element. One, there's 2 words. All my elements have a single name for their names. A single word for their names, sorry. So if I have 2 words, then that helps me know it's got to be a polyatomic. And then also it ends in 8. So this isn't just hydrogen or carbon as my anion. This is an 8, which means it's a polyatomic ion. So I go to my chart, I look it up, and hydrogen carbonate is HCO3-. All right, same thing, I need to cross down. Let me put my CO3- in parentheses. So you get Cr, this is a 1, and then HCO3, and then I keep it in parentheses so I can put the 2 here. See, the 3 stays, everything in the ion stays. I just put the subscript 2. You can't reduce a 1 and a 2, so you leave it alone. I do my check. Got 1 Cr at a +2, so that gives me a +2 total. I've got 2 hydrogen carbonates. Each one of those is a -1, so that gives me a -2. So that's neutral. So then we would just say CrHCO3 2. And we leave the parentheses because there is a subscript there. All right, so that is every way that we could write a ionic compound. Because now we've introduced polyatomic ions, so now we know how to name with polyatomic ions and write the formulas for polyatomic ions. So the last thing we're going to do when we talk about ions is we're going to introduce a kind of subcategory, offshoot of ions called hydrates.